Hi, welcome to our second lesson in AP Statistics. The title of today's lesson is Inference. Yesterday we looked at data exploration, which is gathering, collecting, organizing, displaying data. Inference really means making judgments based on data that you collect. The kind of judgments that you might make involve is the data that I collect, is it showing patterns that are appropriate based on mathematics? Is the data that I've collected, is it working like what happens in the real world, the bigger world? And those are very important questions to statisticians. To help us get an idea about this branch of stats, we're going to take a look at the round 2 people who were hourly workers that were involved in the set of layoffs for this round. I'm going to make a dot plot real quickly of those ages. We had a 25-year-old, a 33-year-old, a 35-year-old, 38, 48, 3 55s, a 56, and a 64. And ladies and gentlemen, those were the ages of the hourly workers who were involved in the round 2 layoff. So after the first set of workers was gone, these are the ones who were left. The ages of the workers who were laid off are 55, 55, and 64. And folks, you can see that those are 3 of the top 5 ages. So we're going to take a look at the average ages involved here. So I'm going to go ahead and add these on my calculator. 25 and 33 and 35, 38. I'll go ahead and finish adding and then we'll skip to the end. Alright, as you can see, the sum of the years that were involved with these 10 workers are 464 years. That's over 10 workers, which means the average age for the entire data set was 46.4 years old. The laid off workers were 55, 55, and 64, which is a total of 174 years divided by 3 people. And that's 58. The average age of the laid off workers was 58. That's significantly higher than what the average age of the entire data set was. So of course what you want to know is, could that have happened just by chance? You know, did West Vaco lay off people because they were old, or did they lay off people because these are the 3 names that got drawn out of the hat? That's kind of what we're going to look at today. The average, the arithmetic average that we've done here, is more commonly known as the mean. That is a summary statistic, folks, and a summary statistic is a number which can be used to represent an entire data set. Represent an entire data set. Now, the mean is certainly not the only of the summary statistics that we will talk about. You're already familiar with mode and median, which are also 2 ways that you can talk about central tendencies in a data set. You might be wanting to talk a little bit about how spread out a data set is, and a summary statistic that tells us that is the standard deviation. Some people use a stat called the mean absolute deviation to talk about spread. All of those are things that we'll investigate further in this class, but for today we're going to talk about the arithmetic mean. And let's see how that can be used to help us make some decisions here. It's a possible dialogue between Martin and West Vaco's lawyers, with Martin coming in first. Look at the pattern in that data. All 3 workers laid off were much older than the average age of all the workers. That's evidence of age discrimination. Of course, West Vaco retaliates. Not so fast. You're only looking at 10 people total. Only 3 were eliminated. If you switched out the 64-year-old with the 25-year-old, the average age would be totally different. Not so fast yourself. You picked the switch that was the most advantageous to your case. Why not look at all the possibilities that could have happened? What do you mean? Well, start with the 10 workers' ages and pick 3 at random. Find the average. Do this a whole bunch of times to see what typically happens. If it's really random, they're thinking, then the average that they get should be close to that 46.4. So let's try that. We have a little simulation model set up here. A simulation is just a way of mimicking with mathematics what's really happening in the world, and you can see that we have 10 tiles here that each have one of the workers' ages on them. I found a website that will allow us to simulate rolling a 10-sided die. This is totally random, and so the numbers that come up will represent one of the workers, and we're going to just pick out some sets of 3 workers and see what the average ages are. In fact, we're going to do this 5 times. I'm going to pick out 5 different sets of 3 workers. We'll figure their average age, and then we'll look at how that compares with when this process is repeated many, many times. In our first set, our first worker is number 5, and that worker was 48 years old. Our second worker, you can't use 5 twice, not in one set anyway, so we got to pick another one. Number 7, who is 55. Our third worker in this set, number 7, come on, can't use you twice. Number 4, who is 38. Alright, and then the idea is we want to find the average age here, so we're 16 and 5 is 21, 65, 11, 141 in total. That has to be divided between the 3 workers to find the average age, and 141 over 3 is 47. Alright, I'm going to do that same process several more times, and then we'll catch up at the end. Here are our 5 trials, results of our 5, found the average of 3 workers selected at random to be laid off. And you can see that our smallest average was this one, 41.3, which oddly enough included both the smallest and the oldest, right? The youngest and the oldest. Our highest average was 49.7. But none of those folks are as old or as close to 58, which Westvaco really laid off, the average age of 58. So you might be thinking, well, that's a pretty good evidence right there. But I'll tell you, one thing that statisticians do to make their averages be even better, right? Lots of trials is important, but then you could get some real high ones, you could get some real low ones. So very often statisticians take the average of their averages, and that's exactly what we're going to do. So we're going to take our 5 averages, 47 and 42.7 and 49.7 and 45.3 and 41.3, which gives us a total number of years here as 226. We need that divided by 5 to get us an average age for our 5 trials. And we're looking at 45.2 years old. Again, that's way younger than the 58 average that Westvaco claimed happened by chance. Let's see how this compares. Our average for 5 trials was 45.2. The data set that you're looking at here, folks, results from 1,000 repetitions. There are 200 dots here. Each dot represents 5 average laid off workers' ages based on chance. Ours comes in at 45.2, which probably puts us right around in here somewhere. Certainly not an unusual value. Now the question is, using our evidence, including all of this, what percentage of the time was the average age of those laid off 58 or more? Well, here's where 58 is, and we have 2, 4, 6, 8, 10 times out of 200. So in 10 of 200 trials, or that would be 5% of the time, just strictly by chance, the average age of 3 workers selected at random was 58. So you think to yourself, well, 5% of the time it could have happened. That means 95% of the time it didn't happen. That seems kind of unusual. And that's the kind of judgment that we're going to be asking you to make today. This dot plot is showing us the variability in a summary statistic. Again, that is the average of averages was our summary statistic. And let's pick up that conversation between Martin and Westvaco one more time. Martin, look at that pattern. All 3 of the workers laid off were much older than average. So what? We've seen that it could happen that way by chance. Well, sure, you could get that result by chance, but is it easy or hard to do? Well, Westvaco must admit it is really hard to get that result by chance, but that still doesn't prove discrimination. Martin's lawyers, no, but I think it leaves you with some splaining to do. So, ladies and gentlemen, the question here would be, how unlikely is too unlikely? How small would that percentage have to be before you think it qualifies as unlikely? Well, I can tell you that many statisticians believe that if something happens less than or equal to 5% of the time, that's considered unlikely. As we go through this class, folks, we will be able to put a little bit more specificness behind that of what's unlikely and what is likely. But a working number to work with is 5% of the time or fewer. That's considered unlikely. All right, as you saw today, performing a simulation can be a useful device for inference, that is, making judgments about the greater population. And the idea is when you simulate, you're practicing what might happen. There are 4 key steps in a simulation, which include, folks, deciding on a model. In our case, we decided on picking 10 numbers at random and associating a number with a worker's age. So decide on a model. And you want in that model the determining factor to be chance. That is, we want to know the determining factor is chance. We don't want to give anything more than equal likelihood of happening. We want to know, can it happen by chance? The second step in a simulation is repetition. And that, folks, is important. You don't want to just do one trial, you want to do many. The more trials you do, the more frequently what should happen will happen. So repetition is important. The third step in a good simulation is plotting the data, so looking at the pattern of the data. And for us, that was a dot plot. And then finally, determining whether it's likely or unlikely that your outcome happened strictly by chance. Likely or unlikely that an outcome happened strictly by chance. Good. Now, in your work tonight or in class tomorrow, you'll be running some simulations. I'd love to show you how to use your calculator to generate random numbers, because it's very helpful and it's something that we'll use frequently in class. To get your calculator to generate random numbers, you use this set of keystrokes. Actually, there are 2. Int, that gives you the integer portion of a number, and then some number of possible outcomes times random. Random is a function on the calculator, plus 1. And I'd like to have you think about this. N is the number of outcomes that you need. So if we were going to talk about flipping a coin, we'd need 2 outcomes. Random is a function in the calculator under the math key and probability menu. 1 is the starting number. So if I wanted to simulate flipping a fair coin 10 times, I would ask my calculator to do this. Int 2 times rand plus 1. Now, there are other ways to do this, and we'll show you some of those others at a later date, but right now this will work for us. The integer function is found under math and under number, so I hit the math key and then over to number. You'll see integer is number 5 there. then it is the number of outcomes that you desire, and we're flipping a coin, so we want 2. We multiply that by the function math to probability and random. That's the random number generator for your calculator. And then plus 1, that means we'll be starting with lucky number 1. So when we hit enter here, the only possible outcomes are 1s and 2s. See? That's all that's going to come up here. And what I'd like you to do is flip a fair coin. It says 10 times. What proportion of your flips were heads? Well, I'll tell you what I'm going to do. I'm going to let 1 equal a head, and I'm going to do my 10 trials right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe that I had 7 heads in there, so I had 70% heads, which is a little bit more than you would expect just by random. Of course, if we were to do this a lot of times, we'd see that 1/2 is what we approach. All right, that's the end of today's lesson, folks. So what I'd like to have you do is try the U-Try as quickly as you can. Remember, that helps me to decide what we need to talk about in class, the next class period. So have a good night.